Hi everyone, great to see so many names popping up. And thank you for the opportunity to present today at this Cochrane session. My name is Annalena Zeitler. I go by my middle name Lena though, which is very confusing. And I'm presenting alongside my colleague Kylie today. And as Daria has told you, we're located at the University of Sydney. And I've put a beautiful picture of Sydney here for you. It actually looks like that. So we both run the Next Generation Evidence Synthesis team at the Clinical Trials Centre, and this group is all about novel systematic review methods, such as searching clinical trial registers, which we'll give you an introduction to today. And before we start, we'd like to acknowledge the Gadigal people of the Eora Nation, which are the traditional custodians of the land on which Kylie and I are presenting from today. And these are our disclosures. I'm not going to read them all out to you. And before we start, we'd like to get to know you a little bit. So I'd like to invite you to join the Slido poll now. You can either use your phone scanning the QR code, or you can use a web browser opening slido.com and using this number 1303344. And please make sure you keep the web browser open or your phone open, because on that same web page, you'll see our questions as we go through. And this is a word cloud, so if you just put in your professional background in a word or two, we will hopefully be able to get to know you a little bit more. Excellent. You can see the first responses coming in. So for the people that have just joined, you can join Slido using the QR code or using the number on the left-hand side. Excellent. Lots of biostatisticians, librarians, researchers. So I feel quite a bit of variation here. Great, health economics. Perfect. Information specialists. Great. Thank you. That gives us a good overview. We may jump to the next question. Have you ever searched clinical trial registers before for systematic review? Just to give us a bit of an idea of who we're talking to today. Wow, and quite a few of you have. That's great. So we're preaching to the converted. Hopefully there will still be some new bits to learn. Great that a few people are here that have never done it before. Excellent. So a bit of a mix. Right. And nice to see lots of people participating in the Slido. All right, I think that gives us a good idea. Keep the Slido open, there'll be more from it. And I'll hand over to Kylie.
Thanks, Lena. So hi, everyone. Just to run over our learning objectives for today. We hope to increase awareness of the importance of searching clinical trial registers, outline the main steps of searching registers, and with a particular focus on key differences to how it's different to searching bibliographic databases. And we also want to show you how you may harness the full potential of clinical trial registries, which we think are a very valuable untapped resource. And to help you pay attention, there will be some quiz questions throughout. So just first of all, we thought it was important to say what we mean when we say clinical trials registers. Seems most of you probably already know, seems though you've searched them before, but they are publicly accessible online databases of planned, ongoing and completed studies. So a key point here is that they include both published and unpublished studies. And they typically include structured information on study design, conduct and administration, but more recently have incorporated results reporting and investigators' data sharing plans. So the largest register is clinicaltrials.gov, which is based in the US, and it has more than 400,000 studies registered. And another important resource is the World Health Organization's International Clinical Trials Registry platform, otherwise known as WHO ICTRP. And this is a database or meta-register, which includes more than 800,000 study records from 18 recognized registries globally. And here is a list of those registries that contribute data to the ICTRP. And as you can see, they do cover all corners of the globe.
All right, and searching those trial registers is mandated for best practice systematic reviews, for example, by the Cochrane Handbook for Systematic Reviews of Interventions. And which brings me to my next Slido question for you. Why do you think that is the case? Why do we need to search trial registries? So this is you can give us answers here. There's several right answers. There are lots of ways why searching trial registries is really important. If you haven't done it before, put your guesses in here. It's really just to get you thinking about why do we do what we do. Excellent. Really important one. Check for reporting biases. Well, publication bias. Find similar research. I think that's a really important one, and ongoing research, and that's something we'll get to a bit later in the session. Exactly, collaboration, planning, prioritization, excellent. Lots of really good unpublished studies, exactly, which I think ties into the publication bias argument. Excellent. I mean, yes, it is best practice. Hopefully we'll convince you that there's a good reason why that is the case, though. Okay, I think that's lots of great answers. So this is what Cochrane says. They say it's mandatory because of the possibility to reduce the risk of publication bias and to identify as much relevant evidence as possible. So your answers were very correct here. And if you give me the next slide, Kylie. Just briefly talk you through this idea why we can look at publication bias when searching trial registries. So in this diagram, you can see an imaginary full study cohort of clinical trials on one research question. And we're assuming that there are about equally as many negative as positive trials out there. Now, what happens, if we go to the next slides, is we know that only about 50% of these studies will publish their results. And most of the ones that publish their results will be positive. So positive studies are much more likely to be published. That is not all. If we look into the publications, we have selective outcome reporting bias. So only about 50% of outcomes will be completely reported. And again, more positive ones are more likely to be reported. So what we have when we look at publications is this very biased subset of mostly positive trials, even though what we started out with were about equally as many positive and negative trials. And that is these are the problems of publication and selective outcome reporting bias. Now, why can search clinical trial registries help with that? Firstly, they can actually reduce publication bias, particularly since now results reporting has become common in registers. So you can extract results directly from trial registration records. You may also want to ask for individual participant data from unpublished studies, or you can contact authors directly for results. If you're not able to get results from a study, at least you can explore the impact of publication bias because you grow a better awareness of how many studies there are that you have not been able to include yet. And also selective outcome reporting, we can reduce or at least understand this bias more because we can compare pre-registered study records to their publications and see, did the authors report all pre-specified outcomes, and ask them if they can supply results for unpublished ones. Now, these are not the only reasons for searching clinical trial registries. There are quite a few other important ones, and it's great to see you alluding to some of those in the Slido. I'll just put this out here for you as a teaser of why it's important to listen to the next bit of the presentation on how to search trial registries, and I'll get back to those in the end and talk a bit more about other exciting opportunities.
Okay, so hopefully you are now all convinced of the value of searching trial registries. The question now is, how do we best search them? And this can be quite challenging because it's quite different to searching bibliographic databases such as Medline. And this is largely due to the varied and relatively unsophisticated search interfaces of trial registers. And also the quality and structure of registration records is quite different as well. And so while there is a lot of guidance available on how to search bibliographic databases, To date, there's been limited guidance on how to search registers. And so often we think these searches are conducted suboptimally or not at all. But luckily, we have addressed this gap and we have developed step-by-step guidance on how to search clinical trial registers. And this was published earlier this year in the British Medical Journal, as shown here. So the guidance consists of 11 steps and several accompanying recommendations on where to search, how to formulate search strategies, screening methods, and reporting searches. So these are all summarized in the figure on the right, and we will go through some of these today, but obviously we don't have time to go through them in much detail. So we encourage you to check out the paper if you'd like further information. Just briefly, before we look at the steps, I thought we should touch on the methods of how we derived the guidance. So first of all, we formed an expert steering group, and that includes those shown in the table. And just the shading is just to give you an idea that this group had quite a broad range of expertise. So those are listed in the first column across systematic reviews, information retrieval. We had a clinician, biostatisticians, so quite a varied range there. And what we did is we conducted a literature review. We obtained information available on trial registry websites. We conducted surveys of our steering group members and expert stakeholders, such as information specialists. And last of all, we held a consensus workshop among the steering group. So we tried to be really thorough in our approach. So in our guidance paper, we illustrate each step using Top Child as a case study. And this is an ongoing systematic review and individual participant data meta-analysis, evaluating behavioural interventions for the prevention of obesity in children. And for this case study to date, the table shows that we have identified an extra 15 eligible trials by searching trial registers. And these include more than 8,700 participants. So this really shows the importance of searching registers for identifying as much relevant evidence as possible.
Excellent. And we have another Slido here for you. So before we take you through the steps of searching registries, we'd like you to have a go at ordering which order you should be doing these steps in. So you should be able to log into the Slido and drag and drop those different options. And I'll give you a minute to just think about this because it's a bit of a more comprehensive task. And while I wait for answers to come in, I'm just seeing I've had a question in the Slido chat if the paper is freely available. And I'm pretty sure it is because BMJ makes all their papers available open access. So yes, it should be available. If you cannot access it for any reason, just get in touch and we can email it to you. But we try to make it openly available for everyone. Excellent. We see answers coming in. What do you think, Kylie? I think they looks like everyone knows.
Spot on to me. Yeah.
Yeah. Excellent. So maybe we can go to the next slide, which shows us the correct steps, which you all got right. And you may have been wondering while you're doing this, wow, this is no different to any other search of a medical database. And this is correct. So the steps are broadly similar, if not the same. However, within each of the steps, there's some major differences. And that's something we will be focusing on when we talk you through them.
So as we walk you through the steps, we will, as Lena said, focus on these differences, but in particular, we're going to point out some common mousetraps to avoid and hopefully make your searching experience a little more straightforward. So look out for the mousetraps throughout the presentation. So as for all systematic reviews, the crucial first step is to clearly define the research question. And this is our research question here in Top Child, showing the PICO elements bolded. So the next step is to determine where to search. And as mentioned earlier and shown here, there are 18 recognised registries worldwide, and it can be difficult to know which ones to search because you want to maximise retrieval of relevant studies, but you want to make sure you can achieve this within a reasonable time frame and without unnecessary burden. Luckily, you do not have to search them all. So as we know, the ICTRP includes data from all 18 recognised registries. So this resource should always be searched. But even though the ICTRP includes data from clinicaltrials.gov, Cochrane mandates searching both of these resources separately since unique records can be found from each. And also clinicaltrials.gov tends to be more up to date and has more search features and generally greater functionality. So for most systematic reviews, it's sufficient to search clinicaltrials.gov and ICTRP as a minimum, but exceptions could include geographically restricted research questions, for instance. So we've conducted studies on where our participants of interest are Indigenous Australians, and for that study, it made sense to search the Australian-New Zealand Clinical Trials Registry. Now, as many of you may know, since 2019, the Cochrane Central Register of Controlled Trials has included registration records from clinicaltrials.gov and ICTRP. However, unfortunately, this is not sufficient to Search Central alone, and that's due to low sensitivity. And therefore, this is not supported by Cochrane guidance. So take care to avoid this trap.
All right, moving on to the next step, which is identifying key search concepts and deriving search terms. And here, step 2 involves, so a key difference to other searches is that you would only focus on 1 to 2 key concepts for searching registers, which are typically the population and health condition or intervention. So a lot less than what you do for medical database, where frequently you'd search up to something like 10 concepts. So it's a lot less, you keep your searches a lot less complex. And before I give you the example of what we did in Top Child, I would actually like you to have a go at thinking yourself for this research question, where we had participants, where we had parent caregiver focused behavioral interventions during pregnancy or infancy on child weight status. Which kind of key concepts would you be thinking about searching trial registries for? Yes, children, very important one. So we would want to think about participants. Excellent. And the participants here are the children. Exactly. The second one, obesity. So that's really the health condition or intervention that we're interested in. Prevention is also an important one, even though it's sometimes maybe too sensitive even here. All right. Yeah, obesity, children. Great thinking. All right, shall we move to the next slide? So what we did, very, very simple, is we only look at overweight, obesity, and child. And really to try to avoid this trap of searching too many concepts. If you look at this table, you can see what we did by bibliographic databases and what we did in trial registers for exactly the same study. So a lot less complex, a lot less concepts to search, because trial register searches cannot handle long and complex search strings.
Yes, so another key recommendation for formulating search strategies is to make sure you adjust these according to the specific registry resource, because the tools and rules are quite varied across these. So this slide just shows a section of a large table which is included in our publication, and it highlights the key differences between searching Medline, clinicaltrials.gov, and ICTRP. So I don't expect you to be able to read it all, just to let you know that it gives some idea of variations across these resources in terms of things like indexing, use of operators, wildcards, filters, available download formats. So just as an example, All databases allow use of Boolean operators, but clinicaltrials.gov requires these to be in uppercase, and ICTRP applies these in specific order. So check out this table for some tips and tricks for adjusting your search strategies. And so this slide shows an example search strategy that we used for top child on clinicaltrials.gov. And as you can see, it is quite short and simple. So if you think about our Medline search for this study, it was 80 rows long, and it included very advanced search syntax. So here we've only searched those two concepts of obesity in child. No filters are applied, no wildcards, no truncation. So nice and simple. In terms of filters, so most registries do offer a range of filters that can be used to refine a search, for example, by study type or participant age. We recommend that these are only applied in exceptional circumstances because they're not validated and registration records aren't subject to stringent peer review. So sometimes they're not accurately categorized. So for instance, in our top child case study, we tested a search string with and without application of the clinicaltrials.gov study type filter for interventional studies. And we identified 3 out of 57 records that were randomized controlled trials as described, but these had been incorrectly categorized as observational studies. So therefore they would have been missed, wrongly excluded if we had used the study type filter. And another common trap to avoid is limiting a search by recruitment status. So reviewers are often tempted to limit their searches by completed recruitment status. And this makes sense because these are the studies that they expect results will be available for. However, this approach should be avoided because recruitment status on registers is often out of date or inaccurate. And also, it's very useful to identify planned or ongoing studies, and we'll speak about more advantages of this a little later on. So step 4 involves conducting the search, removing duplicate records, and preparing records for screening. Throughout this step, it's very important to keep detailed records of things like listed in the clipboard. This is important not only for transparency, but also for reproducibility. And it will also help you complete a Prisma diagram. There are a number of different methods and software available for exporting and deduplicating search records. We prefer to keep it simple. We just use Excel, and both ICTRP and clinicaltrials.gov allow you to export records directly into Excel. But you can also download them into EndNote and upload them to Covidence. But be warned, a lot of information can be lost in this process since the registration records don't have the standard bibliographic structure that maps to EndNote. And deduplication in Excel is also pretty straightforward using the registration ID column and the remove duplicates function. So quiz time.
So yes, we have another Slido to see how well we've presented to you. If we've brought across which sources should be searched as a minimum. Maybe whilst we let people answer this quiz, Kylie, we had a question in the chat from Beatrice asking, will child automatically be mapped to children?
That's a very good question. And the answer is in ICTRP, it would not. CT.gov does have synonym searching. So I think that would be mapped, but I tend to just put them both in just to be sure, make sure the search is sensitive enough.
And I think that's also came across on the next slide that followed after that, that you did actually have both of them in your search strategy for CT.gov. Excellent. So we don't always trust the synonym searching. I think maybe as one of the key rules for searching trial registers, a lot of them were not built to be searched. It's not like a medical database. So if in doubt, adding more words or keeping things simpler, not relying too much on these functions is a good idea.
Yeah, having an adaptive approach, I think, and flexible, particularly with ICTRP.
All right, shall we have a look if people got the question right?
Yes. Here we go.
Excellent. Yes, so clinicaltrials.gov and ICTRP, that's correct. Oh, no one participated. That's a shame. I don't think that's true. And then I assume we have a few people from the UK here. So in your local context, you may want to search your trial registry, which we do with the NZCTR. But if you are looking at international questions, ICTRP and ski.gov should be enough. So next it's time to screen records for their eligibility. And step 5 would be title screening. However, this is an optional step and a step to be very cautious about, because trial registration records are often not as precise as the ones you'd have in a journal article. And secondly, we don't have abstracts. So you need to be careful to not fall into the trap of excluding something based on a title too quickly. So as a general rule, I would only exclude something based on title that is very obviously irrelevant, and anything there's any doubt about or that's a bit uncertain, I would include in the full record screening. Now, when we go to the full record screening, it's important to go back to the registry website to make these decisions. And that's for 2 reasons. First of all, as Kylie has said, often we can't export all information, or information gets lost when we try to export into software such as Covidence. But secondly, registration records are living documents. They are supposed to be quite frequently updated. So you really want to have the most up-to-date version, and you don't want to rely on exported records. So would very much recommend to just go back to the website for this.
Okay, the next step is completing a Prisma flow diagram, which many of you are probably already familiar with, but just to point out that it's good to include the number of records that are retrieved from trial register searches, as we've highlighted in this diagram here. And the trap to avoid here is double counting studies that have both a registration record and a linked publication. So reviewers should be sure to link these together when applicable to ensure that they're not double counted, because this will introduce bias. But importantly, both records should be used to extract the most comprehensive information, but you need to think about how you might deal with conflicting information, because quite often the registration record may differ to the publication. So as for standard systematic reviews, if there are uncertainties about study eligibility, you should contact registrants for clarification. So once eligible studies are determined, attempts should be made to obtain data for inclusion in the review. So Lena briefly touched on this already, but sometimes summary data are available for direct extraction from registries, and opportunities for this have increased since the WHO introduced results reporting requirements in 2015, because this led to more registers adding results reporting functions. So for instance, there are now more than 55,000 studies with results posted on clinicaltrials.gov. Alternatively, you may also obtain unpublished results by direct communication with registrants. And this is a method we commonly use when conducting individual participant data meta-analyses, and we have varying success with this method. So even if results data cannot be obtained, searching registries is still useful to get an idea of how much unpublished evidence might be missing from the review. And as Lena said, you can also evaluate selective outcome reporting by comparing registration records and publications. So we're doing well, 2 steps left. So step 10, report register searches in accordance with PRISMA 2020 and PRISMA search statements. And so the relevant items which are highlighted here require you to specify all of the registered search, the date of these searches, and the full line-by-line search strategies used. including any limits or filters applied. Lastly, register searches should be updated at the same frequency as other bibliographic searches. And to update a register search, you typically just rerun the initial search strategy, but restrict by registration date rather than study start or completion dates. So this can be easily done in clinicaltrials.gov using the first posted field, or on ICTRP using the date of registration. Alternatively, you can just sort all retrieved records by registration date and select the ones registered since your last search. And you should allow a few months overlap to account for delays in uploading records to registers. So congratulations, you have made it through all the steps. And to check you're paying attention, we have another couple of quiz questions.
So the first one is, how many key concepts should a register search focus on? And just while you're finding your Slido again, I'll just answer one other question we've had on Slido, which is, are you going to make the slides available after this excellent Zoom? So yes, the slides will be available, and even the recording will be available as a Cochrane training. So you can listen to us over and over again if you wish to do so. And the other resource I'd like to point you to is the paper that we've been referencing here, which outlines all of the steps in a lot more detail. All right, excellent. So I think 1 to 2, 3 to 5, I think can also still work. 1 to 2 is what we'd usually do. So well done, everyone. So it's really about defining a very small number of concepts. Next question is, register searches should routinely be filtered by? Excellent. So great to see so many people getting it right here. Filters often do not work very well. So studies can be misclassified. In Top Child, we identified an additional 3 studies that had the wrong study type. So they said they were observational and would have been filtered out, even though they were actually interventional. Recruitment status is a very tricky one because it's often not updated. So again, it's really something you do not want to filter by. If you filter by completed studies and then there are ongoing studies that have actually completed, or that you'd want to be aware of for reasons of publication bias. So filters is something we'd strongly discourage you from using unless you just want to have a very quick look at something. All right, so we're back to other reasons for searching trial registers that I promised you I'd talk a bit more about. Before I do so, I'd quickly like to plug another paper Kylie has written, which goes into these reasons into a little bit more detail, how you can untap the hidden value of clinical trial registries. Let's now actually talk about those. One of the main reasons we use trial registries is in prospective meta-analyses. So we, as a conflict of interest, we do run the Cochrane Prospective Meta-Analysis Methods group. So we're very interested in identifying studies when they're planned or ongoing. What is a prospective meta-analysis? It's a meta-analysis for which studies are identified for inclusion before their results are known. So ideally as early as possible, but anything before the analysis can be seen as a prospective meta-analysis. And why would we do this? Next slide. Prospective meta-analyses are generally less biased. So if we include studies before their results are known, we can reduce the risk of publication or selective outcome reporting bias, because we don't know their results when they're being included. We can harmonize outcomes, interventions, and populations. Anyone who's ever run a retrospective systematic review knows how difficult it can be to bring together studies and meta-analyze them. That can also make studies more powerful because we have more of the same outcomes. including rare outcomes that individual studies would not have had the power to and would have not analyzed if they hadn't been included in the prospective meta-analysis. They're more collaborative and more adaptive. All right, next slide. Another reason why we'd want to search trial registries beyond the ones we've already mentioned is to plan updates of reviews. So we can proactively think about which emerging evidence and identify when studies are likely to be completed and can be included. So it can kind of give us an idea of whether it's worthwhile to run updates. And the other main reason is to identify, which some of you have already mentioned in the slider as well, is to identify research gaps and inform research prioritization. So if we want to know whether additional studies on a particular topic are needed, and if we want to avoid duplication of effort and research waste, searching trial registries can be a really powerful tool because they give us an idea about, are there similar studies happening in this area at the moment, or should I be planning one? And if there are similar studies happening, should I collaborate with them? Should we work together? Is my study still needed? Or should I maybe not even be doing this study after all? And we have done quite a few analyses in that direction to inform research prioritization. For example, in this paper where we looked at COVID-19 trials in Australia and found that lots and lots of trials were planned at the same time, addressing the same research question, some of which addressing research questions that maybe less trials would have been needed on, for example, on hydroxychloroquine, which then led to headlines such as the following one, that little gains were made as millions were spent on various studies. So showing how searching trial registries can help us get an idea about the research landscape and inform research prioritization.
Okay, so before we move on to question time, here are a few take-home messages. So searching clinical trials registers is mandated for best practice systematic reviews, including Cochrane reviews. A key advantage of register searches is the ability to access information on unpublished studies, and this can reduce the risk of publication bias and reduce research waste. Searching registers is quite different to searching bibliographic databases, and so researchers really need to be aware of how to adapt the search strategies according to the specific register resource used. And lastly, registries are an untapped resource with many other uses, some of which we've touched on today, but there are more, such as informing research prioritization and facilitating collaboration. So I'd like to acknowledge all of the co-authors and contributors listed here. I'm really grateful that they took the time and expertise to make this project happen.